question 2 from your practice, and I've already gone through and labeled your balanced equation with your data. I have your molar masses provided for you as well, and just a general review of what is a limiting reactant and what is an excess reactant. So remember, the limiting reactant is, at the end of the day, the one that's going to make a smaller amount of product. And so it's going to limit your actual production, how much product you can make. And it's because you don't have enough of it. That's why it's called a limiting reactant. The excess reactant is the exact opposite. You just have too much of it available. You're not going to end up using all of it. It's going to go to waste. And so once you're coming to work through a limiting reactant problem, you're going to want to always be comfortable identifying who is the limiting reactant, who's the excess reactant, and how much product are you going to end up making. And so in this particular question, for question number 2, the two reactants start with the same quantity. They both start with 5.00 grams. And we're going to focus on determining how much of the product in bold we're going to be able to produce. So we're starting with grams of a reactant and ending with grams of a product. And then we're going to compare the grams of the product with both of the individual reactants. So you need your molar masses as well, and those are provided for you at the top of the page. So this is how I start. You're just focusing on one reactant at a time. So to begin with, I'm going to focus on the relationship between my sodium hydroxide and my sodium carbonate. Sodium hydroxide is my reactant, sodium carbonate is my product. And I know that to start with, I was given 5.00 grams of sodium hydroxide, of NaOH. I'm going to try to now figure out, based off that 5 grams of sodium hydroxide, how many grams of sodium bicarbonate I can produce. And so what I'm going to do is I need to first get out of grams of sodium hydroxide so that I can get into Na2CO3, because I'm ultimately going to start here and try to end here. So I know I have to get into moles to use mole ratio. To get out of grams and into moles, I can always use molar mass. And so I'm going to set this up so that my grams cancel. And so I'm going to put grams in the denominator. And remember, molar mass is always equal to 1 mole of that atom or that molecule. So now you can see I'm done with units of grams of sodium hydroxide, and I'm in units of moles of sodium hydroxide. This is now my opportunity to focus on the relationship between sodium hydroxide to Na2CO3. So the relationship between the two of them is that I have a 2 as a coefficient and a 1 as a coefficient. There's nothing written there, so that means it's a 1. So that's my mole ratio, and I'm going to set it up so that moles of sodium hydroxide, moles of NaOH cancel, and I'm left with moles of my product, sodium carbonate. And so now I just need to copy down the moles from the balanced equation. So in the balanced equation, NaOH had a 2, and sodium carbonate, Na2CO3, had nothing. So that means it's a 1. So now if I go back to my units, moles of sodium hydroxide canceled moles of sodium hydroxide, I'm left with moles of sodium carbonate. So from here, I just have one more step to go through to get to grams of sodium carbonate. And that's going to, again, be molar mass. So I'm going to set this up so that 1 mole of Na2CO3 cancels out, and I'm left with grams of Na2CO3. And here I'm going to go through my last set of units, and this is the unit that I want. So now I'm going to go through with my calculator in just a moment. I'm going to save that as my last step. I want to first just set up my string equations. So I'm going to do the other string equation in a different color, and that way we can compare things a lot easier. So let me go ahead and set this up. Again, I start with my data. I have 5.00 grams, but this time of CO2. So if I kind of clear this up for you, I'm still focused on the same thing, but this time I'm focused on the relationship between the CO2 to the sodium carbonate. So I'm focused on the fact that I started with, again, 5.00 grams of CO2. How many grams of my product can I make? So going back to my question, my big picture is based off of grams of carbon dioxide, how many grams of Na2CO3 can I produce? But however, in this particular moment, I need to make sure that I get out of grams of CO2. So in order to do that, that's where I need to use molar mass. So my molar mass is always 1 mole of the element or the molecule, and every 1 mole of CO2 is always 44 grams of CO2 based on the data that was given to me with this problem. And from here, I've canceled out grams of CO2, and I'm now in moles of CO2, and this is my opportunity to do mole ratio. I'm in moles. The moles of CO2 from the balanced equation is 1. The moles of sodium carbonate from the balanced equation is 1. Remember, 1 is never written out. So if it doesn't say anything, it means it's a 1. So this is already just a straight 1 mole to 1 mole relationship, but I need to make sure I write down the name of the molecule. So I want CO2 in the denominator so that they cancel, and I want Na2CO3 in the numerator. So that means that now I'm out of moles of Na2CO3 and I can get to grams. The only way for me to do that is to use molar mass. So let me backtrack and look at the units. Grams of CO2, numerator, denominator. Moles of CO2, numerator, denominator. Moles of Na2CO3, numerator, denominator, and I'm left with grams of Na2CO3. Please notice that you're going to now compare the same molecule. You're comparing grams of Na2CO3 to grams of Na2CO3. You're not wanting to compare different products. So this is now where you could just go to your calculator, and I'm going to take my shortcut of just saying 5 divided by 40 divided by 2 times 106. And my calculator tells me 6.625. My unit is grams of Na2CO3. And when I go here to my other question, I have 5 divided by 44. I don't need to do times 1 or divided by 1, so I can just go straight from 5 divided by 44 to times 106. And this one, I get a much longer decimal value. So I get 12.04545455. And again, my unit is grams of Na2CO3. So let me write that out a little bit neater for you right here. So now I can finally answer all 3 questions that I was trying to, which is, who's my limiting reactant, who's my excess reactant, and how much product did I make? So I have to go through this entire 2-string equation format to be able to answer these 3 questions, and I can now answer them at once. So here's what you want to do. You want to compare your product. You compare the 2 that I just highlighted in yellow to each other, and you always pick the smaller product. Well, in this case, 6 is way smaller than 12, so this is my smaller product. Who was responsible for making the smaller product? That's where I now need to go back and identify who was that reactant. Whoever produced the smaller amount of product, that's your limiting reactant. So that's NaOH. Who, however, produced the greater amount of product, the 12 point whatever, that was carbon dioxide. So carbon dioxide is now my excess reactant. And sodium hydroxide, NaOH, is my limiting reactant. Remember, what you're doing is you're focused on the smaller product. And once you identify your smaller product, from there, you can now see who produced the smaller product, and it was NaOH. And that's your limiting reactant. Your other product, the one that you don't care about, that's the one that is now your excess reactant. So in this particular case, it's carbon dioxide. How much product did you make? Well, it's not going to be this value. It's always the smaller produced. It's always your smaller product produced. So now this is where I need to make sure that I'm dealing with correct sig figs, a unit, and a name. So 6.625, I need to turn that into 3 sig figs because all of my data was 3 sig figs. So 6.625, that's going to end up being 6.63. The unit is grams, and the name is Na2CO3. And those are my 3 final answers to the question.